All right, so this is the last one-step equation type that I'm going to model for you guys. This one has our variable is being divided by something. So this is the weirdest of all of them because it doesn't really fit with the other ones that we've done. Okay, now it does kind of match what you've done before in elementary school. So what I'm going to do this time, instead of using my rectangles to represent x, I'm going to turn x into a pizza, okay, or a pie, or whatever you want to think of it as. And in this case, I'm going to split my pizza into 3 pieces because the denominator in my fraction here is 3. So it's basically saying take x and divide x into 3 equal pieces. And when we do that, we get 2 on the other side. Okay, so I've got my pizza, or it kind of looks like my peace sign, and what I'm going to do is I'm going to color in just one piece of it. Because right now I have that x, and I had one x sitting there, and then it was minding its own business, and it got split into 3 parts. So on my left-hand side, I've got my x that's been split into 3 parts, and one of those pieces is colored in. On the right-hand side, I still have my 2 1s. Okay? And the way I'm going to solve this is I'm going to start by drawing the same thing again, splitting it into 3 parts, and I've got the one piece colored in. And I'll use different colors, okay, in mine here, but you can use the same color at home, but just use this process. So here's what our drawing started out as. When one piece was colored in, I had 2 red tiles on the other side. And what I'm going to do is I'm going to color in another piece, because if one piece is colored in, and that represents 2 red tiles on the other side, when I color in a second piece, I should also get 2 more 1s on the other side, right? Because every time I color in one piece, I should add 2 more 1s on the other side. And then I've got a third piece to still color in, so I'm going to color in piece number 3. And when I color in piece number 3, I need to have 2 more pieces on the other side. So really what's happening here is I'm saying that this was piece number 1 and these matched piece number 1, right? And then I had piece number 1, those matched with piece number 1. When I colored in my second piece, or piece number 2, these guys match up with piece number 2, and these guys here match up with piece number 3. Okay, now you don't need to write all these numbers, and I'm just trying to show where it came from. Okay, so what we did was we took x and we split it into 3 smaller groups, and one of those smaller groups was represented by 2 1s. But when I colored in 2 of those smaller groups, I had 2 groups of 1. And when I colored in 3 of those smaller groups, I had 3 groups of 2. Okay, and so what we have in the end now is I have my whole circle colored in. Now I have all of x colored in, and there are on the other side 6 1s. And so my answer is x equals 6. And if we think backwards, my equation said x divided by 3 needed to be 2. Well, if I take 6 and divide it by 3, I get 2. So that must be the correct answer. So you should be able to, with these models, be able to check in your head because we're keeping the numbers fairly simple for the modeling. Okay? All right, now, how do I do it with a negative? This is even more weird. Okay, so x, and it got split into 4 pieces, so I'm going to split it into quarters. Okay? And this time, I'm going to color in my one piece. And what I'm going to do is I'm going to be very, very explicit here and say that this piece represents negative x over 4. I'm going to write that negative in just so I remember that I've got negatives hanging around here. Now when that one piece is colored in, we have 1, 2, 3 negative 1s. Okay? So as I take that same circle and I color in a piece, every time I color in a piece, I have to make sure that I add 3 negative 1s on the other side. So I've got my first piece colored in and 3 negative 1s, and then I'm going to color in my second piece, and when I do that, I'm going to add 3 more negative 1s. And then I'm going to color in my next piece, and I'm going to add 3 more negative 1s, and I'm going to color in my last piece. And when I do that, I add 3 more negative 1s. And as silly as it seems, I really do want you to, as you color in one piece, add the pieces you need on the other side. Okay, so do it systematically. It makes it much easier to draw the correct amount. Now, the whole thing, because it's colored in, up here it was negative x, and it got split into 4 pieces, but now that the whole thing is colored in, I have negative x. That's a problem, right? Because remember, I don't want negative x. I want a positive x. So what I'm going to do is I'm going to flip it. And instead of having everything colored in, I'm going to flip it and just say now it's not colored in, and we'll go positive. Or if you want, you can color it in something different and say, I'm going to flip it from negative to positive. And I'm going to color it in blue. Well, that means that all of these guys have to get flipped. So instead of being white, now they're going to be red. Okay, whatever I do on the one side, I have to do on the other. And in this case, because I had a negative x, I don't want that. I want to flip it to a positive x. And when I flip it to a positive x, that means on the other side, all my tiles need to flip from being negative to being positive. So my answer here is x is equal to positive 12. Okay? Try another one. No flipping in this one. Okay, so I got x over 2 is equal to negative 4. X over 2, I would color in half of it. That's x over 2 right here. And when I have half colored in, it equals 4 negatives on the right-hand side. But I don't want only half of x. I want it all to be colored in. So what I'm going to do, every time I color in one piece, I'm going to add 4 negatives on the right-hand side. 1, 2, 3, 4. And then I'm going to add in, or color in, one more piece, which means I now need to color in 4 more pieces on the other side. 1, 2, 3, 4. And in total, what I have is x is equal to negative 8. Okay? I was fine with this one because when the whole thing is colored in, it's positive x, there's no negative sign. So you only need to worry about it if there's a negative sign in front of your x or a negative sign on this number in the denominator. Okay? So we'll try one more with that negative there. If you want to pause it and try this one yourself, that might be a good plan. So I'm going to start off with my variable. I'm going to split it into 3 pieces because my denominator is a 3. When one of those pieces is colored in, on the other side, I have 5 1s. 1, 2, 3, 4, and 5. Okay, so I have my 5 1s on the other side. Now do remember that this represents x over negative 3. And since there's that negative there, this is negative x over 3. This is going to represent something that is negative, so we're going to need to do some flipping at the end. Okay, so again, I'm going to start off, I've got one piece colored in, and on the other side that means I've got my 5 pieces. I'm just going to stop coloring them in because I think it's taking me too long and you're tired of watching me color. So I'm going to color in another piece here, which means I need to add 5 more positives on the right-hand side. And when I color in my final piece of the pizza, I need to add 5 more again on the right-hand side, because this says every time we color in a piece, we add those 5 positives on the right. Now, the whole thing is colored in, but it's a negative x because we had that negative back at the beginning, right? We had that negative in front of the 3. And because I had that negative in front of the 3, I've got the negative now is still sitting there in front of x. So what I'm going to do is I'm going to switch everything's color. I'm going to flip this around, and instead of thinking of it as yellow, I'm going to flip it to blue and call it positive x, which means all of these guys need to flip from being red to being white. So there were 15 reds, but now there are 15 whites. And again, I'm not going to color them in just because I'm being a little bit lazy for your sake. But on yours, you should make sure that I can clearly tell that they're either positive or negative. And so now what I have is x is equal to negative 15. And if we take a second to think about this, our question said take x and divide it by negative 3. So if I take negative 15 and I divide by negative 3, negative divided by negative is positive. 15 divided by 3 is 5. So negative 15 divided by negative 3 is positive 5. And we have the correct answer. And that's modeling one-step equations.